Hello and welcome back. So now we are in the final module of this AI/ML workshop, and in this module what we are going to look at is what I am going to call as responsible AI/ML. So far in this course we have been looking at several paradigms of machine learning, supervised, unsupervised, etc., etc., and also we have been looking at some algorithms for each of this. For unsupervised we looked at the k-means algorithm for clustering. For supervised classification problems we looked at several algorithms including k nearest neighbors, decision trees, and so on. And we also looked at online learning, different types of online learning in the last module. In this module, we are going to talk about something slightly different. We are going to talk about responsible AI/ML. Now, what does it mean to say AI/ML is responsible? That's the question we are going to ask, and we will see what might be some reasons why AI might not act responsibly and the need for responsibility in an AI/machine learning ML setup. So, what is the standard practice of AI? So, you collect some data, AI or ML for that matter, you collect some data, and now what you do is you run some algorithm, and we have seen some of these algorithms in this course. We run some algorithm on this data, and what you get after you run the algorithm is a model. For instance, if you are running the decision tree algorithm, the model that you get is a decision tree. And now you can use this model to make predictions for the new data points. And now what we will do is we will hope that this model that we have trained from the training data can be taken and deployed in a real world setup. Now this is the hope, right? So because the model worked well for our training data, we are hoping that it will work well for the test data that comes in the real world, and so we can go and deploy it in the real world. Now what we are going to see are some cases where this model that we have developed will produce unexpected or undesirable results in the real world, and we have to be careful about this, right? So for that, let's first start by asking the question, if you have some data, and now here is an example of a query that was given some time back. If you had googled for the ugliest language in India, Google would say Kannada as the answer. Now clearly Google did not have any bad intention to say certain language is the ugliest language in India. That was clearly not the case. There was some algorithm which was taking as input this query, in this case ugliest language in India, and it was spitting out some answer. And the problem is, what happened with this algorithm and why did this give this answer? Now naturally this became a big problem, and a lot of people raised concern to Google about this, and Google finally apologized for this, and they gave a reason as to why this may have happened. And the reason is, the main point of that reason is this lines that have been underlined here, which says sometimes the way content is described on the internet can yield surprising results to specific queries. Basically what Google was essentially trying to say is that the algorithm is finally working on the data that it is given to it, right? So that is given to the algorithm, right? So the algorithm is trying to do the best with respect to accuracy, etc., and so on, but it works on the data that it is given. Now if the data has some issue, then how can we say that the algorithm is faulty? So Google was saying that the data on which the algorithm it trained was perhaps faulty, right? So it is giving you undesirable results. But clearly this is not a behavior that we want a search engine like Google to produce, and of course Google corrected it later. Today if you try this it won't happen, but clearly there is something wrong with the data and the algorithm was not aware of this, right? So that was the issue. Here is another example, right? So this was some time back in the US, where a system, an artificial intelligence / machine learning system, was used in the courts, right? So in the courtroom, where a judge would use to get a risk assessment of potential people who need to be jailed, right? So, what is this risk assessment? The risk assessment will kind of tell you, if this person is let out of prison, right, so is let go today, what is the chance that this person will commit another crime and then will come back to the prison? That is what the machine learning or artificial intelligence system was trying to predict, right? So, if the artificial intelligence system says, it's low risk of number of 3, then that means that this person has a low risk of committing a crime if this person is let out today. Whereas, if the system feels the person is as high risk, then it would give a higher number, let us say like 8, which means that the system feels this person, if let out today, has a high chance of coming back after committing another crime. Now, in this particular case, you look at 2 different people here. One is on the left, and which is Vernon Prater, and the right is Brisha Borden. Borden was given a high risk, whereas Vernon was given a low risk, right? But what really happened is, Borden, the one on the right, when she was so both of them had done similar kind of crimes or to get into the prison, right? So, Borden was rated high risk for future crime after she and a friend took a kid's bike and scooter that were sitting outside. But when she was let out, she did not reoffend. On the other hand, when the person on the left, the Prater, when he was let out, he committed a grand theft, right? So, after going out, that is the person who the machine learning system thought was a low risk ended up committing a big crime, whereas the person whom the machine learning system thought was high risk ended up not committing any crimes at all after being let out, right? So, clearly there seems to be an issue here, right? So, the system seems to have gotten things incorrectly. Now, prior offenses before, based on what the system was actually making this decision, Prater had 2 armed robberies and 1 attempted armed robbery, whereas Borden had 4 juvenile misdemeanors, right? So, juvenile is when she was, young, right? So, in the age of in teenage, let us say. Now, the question is, why did the machine learning system think Borden was at high risk than Prater, when both of them had very similar crimes? In fact, Prater's crime seems to be much more problematic than Borden's crime, which is 2 armed robberies. But still, Prater was labeled low risk and Borden was labeled high risk. But why was this the case, right? So, now if one analyzes this in the context of race, right? So, in the context of whites versus African Americans, Prater was a white person, Borden was an African American woman. Now, the table here shows something starkly problematic. So, those who were labeled at high risk, those the system thought were very high risk people, but who did not commit another crime after being let out, 23% were whites, whereas around 45% were African Americans. That is, 45% of the African Americans, the system labeled as high risk, but then they did not commit any crimes, whereas only 23% the system thought were high risk were white people, but they did not commit any crimes. On the other hand, those whom the system thought were low risk, but they ended up committing crimes, right? So, these are the people whom the system thought were okay, they won't commit a crime, but they actually ended up committing a lot of crimes. Now, 48% were whites, whereas only 28% were African Americans. What is this saying is that the system somehow is giving a high risk or a low risk score based on whether that person is an African American or a white person, more than whether what type of robberies they committed or crimes they committed. But that's a bad thing, right? So, just because somebody is of a particular race or a color, or a religion or a gender, right? So one cannot decide on a risk factor for reoffending. The risk factor should depend on objective things like what kind of crimes this person commit, etc., right? But there seems to be a very high correlation between race and the type of risk scores that were given to these people. Why would this happen? Of course, the AI/ML system itself is inherently not racist, right? So it's not biased towards one race or another race, but still it happens. And why does it happen? Because the system itself was trained on data. And what kind of data would it have been trained on? It would have been trained on data of people who were given certain prison sentences in the past. And these prison sentences were given by judges who perhaps had racial preferences. Perhaps the judges earlier were preferring whites to have less prison time than the African Americans. So if the judges were racially biased, the data will become racially biased, on which the AML system then trains, and now the model that it builds from the data, using whatever algorithm it may be, the model is going to also be biased. So if we deploy this model on real world data, we are somehow propagating the implicit bias that is there in the data. In this particular example, the bias is a racial bias, and that gets propagated to real world scenario, and that's a very bad thing, right? So we should not allow AI systems to be racist, right? So we don't want that to happen. Here is another example where the AI system was not racist in this case, but then was sexist, right? So it was deciding, so this was used several years back by Amazon, where an AI system would look at the resume of a person and then make a decision. It will run a classification algorithm and decide whether this person should be called for an interview with Amazon or not. Amazon is a e-commerce company, as all of you will know. Now, what kind of problems did the system have? Well, when there were two people who had very similar qualifications, they had done similar degrees, they had gotten similar amount of marks, etc. If there were two people, now this AI system was preferring the male to be called for an interview than the female. But that's a very bad thing, right? So because if two people are exactly qualified in the same way, then it should not matter what is their gender to decide whether they'll get a job or not. Whereas the system was in fact biased towards, positively biased towards the male gender as opposed to the female gender. And again, why did this happen? Well, Amazon as a company does not want such biases, right? So which means that there is no intentional problem here, right? So it's an unintentional problem that an algorithm, binary classification, supervised learning algorithm has picked up from data. Now what happened, after people analyzed this, is what they found out was the data on which this model was trained was on people who were at Amazon during that time. And Amazon at that time had more male employees than female employees. So what the machine learning model has figured out somehow incorrectly is that gender is enough to decide whether that person should be called to an interview or not, as opposed to the real qualification. Because the model does not know the power of using either gender versus qualification. For the model, for the algorithm, these are just features. Gender is a feature, qualification is a feature, and then it's trying to figure out which feature is a better feature to predict the outcomes. And now, it doesn't know that gender should not be used as a feature unless we explicitly tell the model so, right? So now one might ask, well, why can't I just remove gender from my data set if I know that gender is going to have a problem? Or why can't I just remove the race from my data set in the previous example, whether that person was white or African American. Now the issue is, one cannot necessarily say that by removing these features you have made the model fair. That's not true, because there might be other features which are highly correlated with this feature that you have removed, which is the gender or the race. Let's say in the US, if you want to think of race as a protected feature, you don't want the algorithm to use race, but then you may have some feature like a pin code, and what might happen is a pin code corresponds to a geographical location in the country. Let's say your home has a pin code. Similarly, in the US, every place has a pin code, and this pin code, people living in this pin code might be predominantly from a particular race, either the whites or the African Americans, right? So that's how people, live in the US, right? So some areas are predominantly white populated areas, some areas are predominantly African Americans populated areas. Now, if pin code is part of the data set, then, and if it somehow thinks pin code is very important, and because of the correlation between pin code and race, it is implicitly thinking that race becomes a very important thing to make a decision about the risk score. Similarly, some other feature might be there which might be very highly correlated with the gender for the recruitment tool problem, and that might end up having a lot of issues. So basically what is necessary is, we want to develop fair and socially good AI/ML systems. And for this, what one has to do is one needs to first decide what does it mean to say an AI ML system is fair, and how can I convince in a court of law that something that I think is fair is actually legally allowed, right? So the main point that I want to try to make here in terms of responsible AI is that if an AI system is responsible, then one part of that responsibility lies in being fair, right? So it should not make decisions based on race, religion, caste, gender, etc., etc., right? So it should only use relevant features to make decisions, and so it is our responsibility to make sure that the AI ML algorithms we develop do not use these features or some versions of these features which will lead to unfair outcomes to certain groups of people, right? So this is one important thing to keep in mind, so that AI ML systems must be fair. Right. So now we are not going to discuss how to make AI ML systems fair. That's not in the scope of this workshop. If you take again a full AI ML course, you will understand what kind of algorithms people are thinking about to make these systems fair, not just highly accurate, but also fair. And that's a challenge, right? So and a lot of new algorithms are being developed today to achieve this objective. So this is objective number one, right? So a responsible AI system must be fair.